So my neighbor recently acquired a Hammond Model M3 organ and is in the process of restoring it to have at his house. He has a little area where he has a lot of musical instruments set up and kind of have some fun playing in the shed, you know, playing music, and this will be a nice addition to that. And when he got it, the cabinet and everything was in really good shape, but the tone generator was frozen up and the amplifier was not powering up properly, had some issues. So he is in the process of restoring the tone generator section, and I have volunteered to take this amplifier that you see right here and totally restore it and make sure that it is reliable. We want this organ to be reliable because we know that one never likes it when one's organ fails in the middle of one's favorite piece. Now, working on one of these amplifiers out of a Hammond organ is not at all like working on a guitar amp or something. Now, in some ways it is. There is, you know, your basic amplifier in here. This one uses 2.6 V6s in push-pull, 12AU7, 12AX7, some things that we're used to seeing. But there's a lot more going on this chassis than just the power amplifier. This is a very unique circuit, and it's something that should be a lot of fun to work on, and maybe we'll learn a few things along the way about how these things work and how they were designed. So if that sounds interesting to you, stay tuned, and that's what we're going to do. Now, the first thing we need to do is determine which model of amplifier we have. So there were several different production runs of the Model M3 organ, and this was a very, apparently, I have a cousin who is really into this stuff. He collects Hammond organs, and he really knows a lot about the product. And when I spoke to him on the phone about this, he said that the M3 is actually a pretty unique organ. One of the unique features of it is its percussion amplifier. It's a little bit, it has a sound all its own compared to the other Hammond organs out there, and this is a very desirable organ because of this. The other thing is it's small, and you know, kind of a compact spinet cabinet that it comes in, and I guess some people refer to it as the Baby B because it's kind of like a scaled down version of the very famous B3 organ. So some of you who are into this type of instrument might know that, and those of us who know less about it, well, it's a learning experience. So very interesting. And you can see this schematic. There's a lot going on here. Of this entire chassis that we're going to look at, only this tiny little section up here is the amplifier. The rest of it is circuitry to make the other parts of the amplifier work. So there's quite a few things we have to check on this thing. Okay, hopefully I have a decent overhead view of the schematic. We'll try to go over what this is all about here briefly. So first of all, there are three different versions of the schematic for the M3. And the earlier ones, the main difference, the two earlier ones, the main difference was that, and I'll just hold this here, in the power supply you see there's a field coil for the speaker because they were using an actual field coil speaker or an electrodynamic speaker instead of a permanent magnet speaker. And in the later version, you can see that's been just replaced with a 180 ohm power resistor. That's the main difference. There were a few little component changes, I guess, but that was it. So the one that we have is the later model, which has the permanent magnet speaker. So this is a schematic we're going to work with, and that's why I wrote this one on it. The amplifier section is actually pretty simple. It is your basic 6V6 push-pull amplifier, and I think I can zoom in on this a little bit. Not much to it. They call this the intermediate amplifier. There's a reason for that in a minute. I'll explain it. The expression control, which this is your volume control pretty much, really unique how it works. It actually uses capacitive coupling. It's not a variable resistor. It's not a potentiometer. It's almost looks like a tuning capacitor. And well, I could show it to you real quick. Okay, so the expression pedal connects to this little lever right here, and I can back you up here. You can just see it's just a little lever that attaches to the foot pedal, which is your expression pedal. And if you look down inside there, there's two things inside this little shielded box. There's a variable capacitor that allows you to adjust, to fine trim it. There's a auxiliary input for like a phonograph. See, that actually mixes the signal in with this, and it just has a dummy plug attached to it. You can see, I'm not going to force it, and it just couples through this little ceramic disc cap. And when you move this, you can see there's one of those potato cutters, as they call it, or whatever you want to call it. It's a variable capacitor. So you can see the fins down here. There's the stator and there's the rotor moving back and forth. You can kind of see it stick out the ends. And by adjusting the shaft, you can adjust the throw of this thing and everything. It's all mechanically fine-tuned. But this is how the volume works. There is no actual potentiometer, and that's really cool, because a lot of problems with volume controls that are foot actuated is that pot moving back and forth, it wears out. This is never going to wear out because there's no parts coming in contact with one another. Very cool. And there's a little adjustment screw here to adjust the tension. So this actually has a little bit of friction to it, and you can adjust that. It's a very, very cool system. So I just thought you'd be interested in seeing that. Okay, so we see how the volume works here. Other than that, you have your basic voltage amplifier, and you have your phase splitter right here, which is basic cathodione, and then that goes into a fixed bias. You can see the cathodes are grounded, 6V6 push-pull amplifier. It does use some negative feedback, and that's kind of unique how they have the 200 ohm resistors and they're coming out of the center point. And then this C23, that's the actual trimming cap that you see on top of that volume that I showed you. And you can see it's set at the factory. This is actually setting the frequency at which this feeds back. So it actually shapes the negative feedback so that at certain frequencies it has more influence and other frequencies it has less. And you can imagine how that would be very important with all the different notes. We'll look at that in a second. Now when you come back to the intermediate amplifier, this is kind of where all the signals converge. So if you look at this point D down here, you have your vibrato section, which is here. We'll talk about that later. Your percussion amplifier right here. We'll talk about that later. And then your actual notes from the keys, when you push the keys, coming from the tone generator. And the tone generator in these is very unique too. It's electromechanical. It uses a whole series of, well, I showed you that little picture earlier in the video. It's a whole series of little wheels with flat spots on them, little discs, metal discs, that are passed in front of like a little magnetic coil. And as the little corners of those, the flats and the corners pass by in a rhythmic pattern, it'll actually produce a note through that pickup coil. Kind of like a guitar, how a guitar, electric guitar works when the metal string vibrates in front of the pickup. Similar idea. There's quite a few tone wheels. The more tone wheels, the more notes that it can produce in different ways. I'm not going to really get into how that all works in this video because this is really about the amplifier. But you can see all the drawbars, which are the different shapes and tones you can get from the tone wheel section. And they all kind of mix together. You have a matching transformer, and all of the notes from all of the keys and the foot pedals and everything all mixed together, and they come in here on point A. Then some of the signal, you can see, is fed down into what's called the percussion amplifier. This is a really unique feature that is made famous by the Hammond organ, and I put up a little description of what it was earlier. But I guess in this, I'm repeating what I heard, so I'm not an authority on this. I'm just repeating something. So any of you that know more about this, please share with us. But apparently, the design of this percussion amplifier, when compared to some of the newer and some of the other versions of the Hammond organs, this one is a little bit unique on the M3. Apparently, when you turn the drawbars off, in other words, you turn the notes all the way down, all the different tones, this will actually act almost like a chime or a bell or like an electric piano kind of effect, like, you know, a plinking sound when you hit the keys. And I guess it's very unique to the M3 when you compare it to that effect on the other versions of Hammond organs. Again, this is hearsay. This is what I've heard. We're going to try that out. I mean, I'm definitely interested when my neighbor gets that thing up and running. Hopefully he'll get it going. So you can see all the transformers and for the coupling. And this little amplifier here, it just uses a 12AU7, and then comes out of the transformer, and then it couples into point D as well, which goes up into the intermediate amplifier. This is kind of your mixer section where all the sounds mix together. In addition, you come out of the tone generators and the drawbars and everything, and you go into this vibrato channel. Now this is another thing that's very unique. Most vibrato that you see like on guitar amps and everything is actually tremolo. In other words, it varies the volume up and down of the sound to give you that kind of vibrato effect. But true vibrato doesn't vary just the volume, it varies the pitch. So it'll take that note and it'll shift the pitch up and down. And this does it in a very unique way. This is true vibrato. Now, first thing we got to talk about is one of the things that makes the Hammond organ very famous is the speakers that they used on it, which were made by another company called Leslie. Now, I'll put up a picture of a Leslie speaker. I'll show you the front and I'll show you the back and some of the parts in it. But the Leslie speaker produces a sound of its own. It's its own type of, I guess you could call it vibrato, but it works by moving the sound towards you and away from you, much like if you ever hear an emergency vehicle with its siren going and it goes past you. When the vehicle is coming towards you with the siren, it has one pitch, and that pitch changes as it approaches you. Then as it passes you by and goes away from you again, it changes again. And the Leslie speaker works on that same principle. So that is a different effect than the vibrato built into this. This unit uses what's called a vibrato scanner. We looked at the expression control, that volume control. Well, they have a similar thing. You have this metal can, and inside the metal can, again, is these fins, almost like a capacitor, a variable capacitor. And they rotate. And you see this little rotating piece around here. And it rotates towards all of this series of coils and capacitors, which will shift the pitch. I've not really gone through and tested one of these a whole lot. but I'm very interested in seeing how this effect works. I've heard it before, and it's very good. It's actually a very good sound. Now, some of the Hammond organs will have this, and some of them will also have a Leslie speaker, licensed by Leslie, built right into the cabinet. This particular one does not, so the only vibrato effect you get is from this. I'm sure you can connect an external Leslie speaker if you wanted to, but it's not really like the Hammond B3, which was really designed, did not have an internal amplifier or speaker, and you had to connect an external speaker to it, which was almost always a Leslie speaker cabinet like I just showed you in the picture. And this allows you, and you can actually adjust the amount of vibrato, so you can make it, more or less, small or normal. You can also have a volume of the vibrato, so like how much it feeds in. All of this stuff is adjustable. It also has vibrato chorus and vibrato normal, okay? And again, I'm not 100% sure. I'll post I'll post a little note what this is if I remember. So all of these things come together and go into this amplifier, and we just want to make sure that that these tubes are working on this chassis. And as you can imagine, each one of these inputs has a different input impedance and different gain. So some of them will have this is a much higher signal in here, I believe, than the other ones. Or it might be much lower. You could see this is a 6AU6, which I think is a pentode tube. So there's a lot of gain here, possibly. And then it goes into the 12AX7 triode and then feeds the expression control, which goes into your normal amplifier here. So we're just going to go over all this. And the main thing that I'm concerned with is the capacitors down here, because I saw one of them, and I think it's either this one or this one, had leaked, and we're going to go and test all of them. And there's a couple of electrolytics that are used, small voltage ones, like 25 microfarad, 25 volts. We're going to check those and make sure they're not leaky. Most of them are going to be, by now, they're going to be high ESR. It's not going to damage the circuit, but it is going to affect the sound. So you want to replace them if you want it to sound like this one here that's 30 microfarads at 25 volts. This bypass cap here, you're going to want to make sure that that is correct, or it's going to change the performance of this. So anyway, we're going to go through and check it, and hopefully we'll get this amp working and working like brand new. Now, another thing to take note when you work on these organ amps from Hammond, these usually come with a cover over them. Here's your mains connection. It is tied directly to these three terminals here. So if you touch these, you are getting directly across the mains with no fuse. So yeah, it'll light you up. And all of these connect to the different parts of the tone generator and the pedals and all kinds of things. So there are a lot of different connections in here with exposed voltages and all kinds of, you can see. So this is something you have to be really careful when you work on it. You can't just, you have to be careful. All right, taking the bird's eye view of this, and I can't even, this is a really wide chassis, so I can't get the whole thing in frame here without really moving the camera way up on the stand. But the first thing I noticed is there's some crust on this one capacitor right here. So we may have some issues with the caps. We need to check them and make sure that they're not shorted, or something not going to cause damage to the 5U4 tube. One of the tests that we did when he just acquired this thing was I actually removed the 5U4 rectifier tube, and so that he could power the unit up to see if the tone generator worked, and the tone generator did not work. It was locked up. but I didn't, if any caps or anything were bad in this, I didn't want it to power up. So that's one way you can power this chassis up without worrying about the high voltage coming up and damaging, you know, the tube and the transformer and all that. I'm kind of glad I did that now, because I see this one cap looks leaky. Let's just do a basic test. We'll check a little bit of the leakage with just a multimeter or a volt ohm meter, and we're also going to check right now the ESR to see what this looks like. These are, I believe, 40 microfarad, like 450 volt caps. So go from here to here. That one's good. And you can see that capacitor is totally open. So the one that's all crusty is totally bad. If I move over to this side, this is one of those paper isolated capacitors. And the one over here is a metal can capacitor. And we'll check each of those. That one's getting a little tired. Not bad. Not bad. So it's okay, and possibly this one, when we power it up slowly, it may reform and be okay, but I don't know if I'm going to leave it in there or not. I may just go ahead and change it. Because again, we want to make this thing last for many years to come, so I'm not going to play around with it. The reason I'm testing these caps is just to see if we can put power to it to see what does work. And if I see too many caps shorted and so forth, then I'm not going to do that. All right, let's look at this one. That one's pretty bad. How about this one over here? Also pretty bad. So the electrolytics are not very good. Let's look at the film caps or the paper caps. And again, I'm not going to use anything fancy. I'm not going to check them out of circuit with the capacitor analyzer. We're just going to use a good old-fashioned triplet 630. The reason I like this is it uses a 30-volt battery. You can kind of see up in here. That's a 30-volt battery. So it puts some voltage across these caps when checking for shorts. And I'll set this up here, make sure. Okay. And what I'm going to do is I'll move this forward a little bit. I'll move this here so we can see it. Let's see if I can get everything in shot. And let's look at some of these capacitors now. And again, this one can check up to 20 to 30 mega ohms. It'll check. It'll go quite a bit. Actually, it'll go even above that on full scale. It'll go way up there. So we just want this to be about 20 megs or above. And you can see that's reading pretty much open circuit. That's a good cap. And these are in circuit. Okay, this one's got a little bit of leakage on it. See that? It's not bad. It's reading about 5 mega ohms. So that one's, if we're not reading something in series with it, that cap is leaky. It's too leaky. That one is reading 20 mega ohms. So it's just good. Again, these are all things we're just testing to make sure that we don't have anything that's going to cause any problems. None of these are going to short out and cause problems. That's all we care about. Okay, the first thing I want to do here is some basic voltage checks. And I have this thing set on the dim bulb, and I only have a what is it, a 40 watt bulb. So I'm really limiting it. And in order to get this thing to work, you have to jumper this mains lead to the transformer, because that's done outside the amplifier on the power switch that's on the console itself. So the first thing we're going to do is we're going to connect this up very gingerly, and the bulb is lighting up and it's dimming down a little bit. So I'm thinking the filaments are at least getting some voltage. So let's check and see. The first thing we're going to look at is see if we can get, if we're getting our 5 volts. I'm doing this around the camera. And it's 4.1 because of the dim bulb. We're also going to look at the high voltage winding. And you can see 490 volts. And to the center tap, I have 245 on one side and 245 on the other side. So that's good. Let's see what else we have here. If I go from here to here, okay, that's good too. If I go from the chassis, and I'll get the camera back where you can kind of see it. If I go from the chassis to that line, I should read 180 volts, or 180 ohms, and I do, 187 ohms. So that's good. So all of our voltages at the transformer are good, and they are there. And we know that this power resistor right here, which is taking the place of the field coil from the earlier model, that it's good. Okay, I have our power connected back up. And going from this lead to this lead, there's 4.6 volts AC. So we do have filament voltage. Again, we're going through the dim bulb, so the voltage is going to be a little bit low. So while we're going to get a lot of hum because that one capacitor is bad and the other ones are kind of tired, I do think that at least as long as we leave it on the leash here, it's safe to put the 5U4 in there and check to see if we have any, if we have voltages, and we can also connect just a speaker to see if we do get the hum. Okay, let's plug this thing in, and I'm going to go to a little bit larger bulb because there's a lot of circuitry in there, and that looks good. And let's go between chassis and the output, which is this red wire here, and I bet you it's going to be ugly. 220. You can see it's dropping rapidly. That could be because the tubes are heating up. It also could be because that capacitor is shorting out. And I can see the bulb getting brighter. What's going on here? And you can see the voltage still dropping a little bit. And if we look over here, 125, 179, 186, and nothing there, 0.7 volts. So I think we have some shorts, and it could have to do with these capacitors. Again, it's starting to stabilize a little bit, but this one here, yeah, it's way down. So yeah, we have a few problems that we have to address. Okay, I have a speaker connected, and I just want to hear if we can get some hum. Very good. So we know that the amplifier section is at least somewhat working. And again, I still have this limited, current limited, but I'm really not getting a lot of hum. Even though we have a totally open capacitor in there, we're not getting a lot of hum. So I have a feeling some of these caps are reforming, although this cardboard one is definitely shot down here. I don't think there's going to be a whole lot to do on this amp. Clean it up, make sure the tubes are good. And we might have one film cap that if it doesn't have something in line with it, it might need replaced. And everything else, you know, a couple of these electrolytics. I think this thing's going to be ready for the races. All right, so here we can see that these capacitors have become crapacitors. The 25 microfarads is reading 41. The ESR is almost 8 ohms. V-loss is 1.8%. It's bad. And this other one here, and it's reading 43.9, 8.7 ohms, even worse. And look at the V-loss on that, 6.3. So these are shot. So you can see that that little ESR meter does give you an indication. Now remember, ESR is measuring the series resistance or series equivalent resistance in a capacitor. It doesn't tell us if the capacitor has leakage. It doesn't tell you if it's shorted. But a high ESR capacitor can indicate that it's bad. Okay, so that's a quick and dirty test when you're just going through real fast, and you can see that that pretty much vetted these ones out. And like I said, 3 of the 4 in this metal can were starting to read higher ESR. One capacitor on this on this paper cap down here, this paper coated can, was open, and the other one was reading okay. It probably would have been okay, at least for now. But in a multi-section can, if one of the sections goes bad, you can pretty much guarantee the rest of them are not far behind. So capacitors are replaced. You can see what we did here. We just kind of put axial lead ones underneath, and we utilized the existing terminal strips because there were lots of empty terminals to work with. So for instance, this one that was over here, it was in this way. We were able to just move the ground wire up here and put this small one in this direction. And we were able to relocate this one here that had an extension wire going down here. We were able to just put it right in with these other caps here. So that worked out well. The 2 big ones that were in this cardboard can, we were able to just put them right over top of it, and we were able to just add one little 2-terminal strip down there, which held it perfectly in place. And then these last 2, one of them fit in 2 of the terminals here, and one of them fit in 2 of the terminals in between here and here, and they fit perfectly. These are 105-degree capacitors. They're pretty good ones. They should last as long as the owner lasts as well. So anyway, let's do another power up. Okay, I have the 5U4 plugged back in, and we're still on the leash, and we're looking at the dim bulb right now. I'm going to plug it in, and what we should see is once that 5U4 comes up, that bulb should get bright as the caps charge. Then it should dim a little bit, then it should brighten back up again as the rest of the tubes warm up and start to conduct. So here we go. All right, it got bright, dim, now brightened just a wee little bit, dropped back down, and you can see it's getting dimmer. And I'm watching the watt meter, and now it's starting to climb up. The bulb is getting brighter. We were at 80 watts. We're at now 90, 91, 92, 93, 94. And you can see it's getting brighter. You can kind of see down here 95. So everything's starting to conduct. Now let's go over here. Hopefully nothing's going to explode on us. Now it's settling somewhere around 96 or 97 watts. So we're coming straight out of here, and we go through a 30 ohm resistor, and we get to our 320 volts, and the 320 is on that red lead that we were looking at from the transformer. So here's the red lead on the transformer. Goes over to here. This should be 340 volts. Okay, let's try this once again and see what we get. There it goes. That's what I thought. I wasn't connected. I wasn't making good connection to the contact there. So it's 275 volts on our, what is it, 320 it's supposed to be. And I would believe that because I have a pretty good current limiting bulb in there right now. So that B plus is going to be low. I expect that. And you can see it's dropping as the 6V6 output tubes start to conduct. And I would have to think, hold on, I would have to think that that will come up once I bypass it. Let's add a little more bypass to it, a little more current. Oh, and it jumps right up. Look at that. And I still have current limiting in there. So if I take all that current limiting out of there, I think we're going to be right where we need to be. Okay, let me shut this off for a minute because I don't want to poke around in all these voltages because it's kind of hard to get down in there. And let's check our bias on the output tubes. Okay, that was pretty convenient. So right at the tops of those two coupling capacitors is where we can check our bias into pin 5 of the two 6V6s, and we should have minus 19 or negative 19 volts, but because we have the current limit in there, it's down to minus 11.6, but that's good. That'll be fine. Again, that'll come up when we take the current limit out of there. And I am hearing hum, and I can move the mic closer to the speaker. So you hear that. And the reason that there's so much hum is all of the input terminals there's multiple inputs along there. All of those are actual inputs to the amplifier. So there's a lot of open circuits with no termination on them right now, so you are going to get a little bit of hum. That seems acceptable. So the amplifier is working right now, and I'm really happy. Now, ain't this just the cutest little old signal generator you ever did see? I love this thing. I made it from a kit. I got it really cheap on eBay, I think, or someplace. And I attached this little battery pack that holds, what is it, 8 AA batteries, so it should run for a really long time. And I just Velcroed it on there. It came with this little plug and everything. There's a little on-off switch. So it's all isolated. It runs on its own little power. You could just connect a little oscilloscope probe like this, and I just put a little capacitor in the end, and I have it set to times 10 just to give us some isolation, and then we can turn it on, and then we can go over here and see if we can get it to make any sound. So let's go. Yeah. All right. Amplifier works. So now we'll look at the schematics and look at the other parts of this chassis to see where else we can inject some signals to make sure those parts of it are working as well. Once we do that, we know this thing's ready to go, and we'll just clean it up and it'll be ready to take over and attach to the organ. Alright, looking over here at the percussion amplifier, this little 6C4, if I go right into pin 6, I should be able to inject a signal with our little makeshift signal generator here. So let's go. Oh yeah, that's good. So our percussion amplifier is working. Let's look at the manual amplifier, and that's coming in on position A. and that's on V2. V2 is this tube right here, so it's the 1, 2, 3, 4, fifth one over, and we're going into the, let's see, right here, right up there. So that's going to be pin 1, so it's going to be the 47K resistor going into pin 1 of V2. Let me get over to that. Okay, that leads from the 6AU6 up to here, and from there into this wire up into here, so I should be able to get something out of that. Oh, I'll take my hand off there so I don't put all kinds of hum on it. Yes, and it's low amplitude, so that's okay. So you can hear that. And that one's working. So all the different inputs are working, and again, they all have different gain levels. This end, this part right here is going to be controlled by the expression pedal, which I have just sitting free floating down here, so that's going to be reduced amplitude. Everything's working, and the amp's quiet. I mean, other than everything, all the terminals being wide open. The tubes are running pretty cool. Our wattage is staying very stable. I think we're good. All right, this thing's really handy, so I made myself a little probe for it. You can see it just consists of a old meter probe and an old coax cable and a little ground lead coming from the coax, just some heat shrink magic and a capacitor in there. And now I can go through and I can check this one, and you can hear the different so all the inputs are working properly. There's a real low input there. So it's all good. Okay, we got the top side of the amplifier cleaned up, and it cleaned up really nice. We cleared off all the terminals, cleaned the tubes, cleaned the chassis, polished off these were aluminum covers, bell covers on these transformers. They cleaned up really nice. We put a new power cord with a ground on this, which it really needed. The old one was very bad. Let's take a look underneath. Now, of course, underneath we've already seen the capacitors we replaced. We also put a new XY safety capacitor in place of the other one. We could have put a little different configuration, but I think this is going to be fine with what we have. I also added a fuse holder. Now, this fuse is a pretty high amp fuse. It's not really here to protect the amplifier. It's actually here to protect all the things that are going to connect to this terminal outside here, including the start motor, the run motor, all the outside parts, in case a wire would actually, would accidentally short. Rather than burning up the power cord and blowing the breaker on your wall and everything, this fuse will go away. But it's really not designed to go away if a tube shorts or something like that. The amperage is a little bit too high. So everything's cleaned up and working well. I'm going to connect a speaker and just feed some signal through it to test it one last time, make sure everything looks good, and if it does, then we're just going to go right ahead and close this video out. Alright, how's that for a janky setup? So here's the input to the amplifier. At least I'm kind of tagging in right here at this point where the different modules go together. And I have a speaker connected kind of loosely. I have my my stereo to mono converter. I have the buffer amplifier, and I'm kind of using that up there for the volume control and everything. And so there's all kinds of computer noise from the sound, from the interface and so forth, just the way it is. But anyway, just to test this thing and make sure sound goes through it. So you can hear when I move the mouse around. You can kind of hear that. That's from the computer. So let's start a song. And this thing sounds pretty good, actually, I think. Now, let me take the microphone off my shirt here. All right, so not too bad for kind of something hacked together on the bench, but amplifier's working fantastic. It's clean, it sounds good. The expression pedal, I'll turn it back up here for a second and I'll show that to you. So right here, you can see that works. And it might need a little bit of adjustment setting the threshold down here, but we could take care of that later. Yeah, this is good. So I think we can safely say that this amp is ready to go. So what we're going to do is I'm going to unplug this for right now. And this is going to be a wrap on this. Now, I'm going to end this video right here, but we are going to do a second part to this. And the reason is the owner of the organ wants to be able to switch between the internal speaker in the organ itself or switch the speaker off and go to an external output that he can tie into his mixing board, because he has a mixing console and a kind of a PA system in his kind of shed garage thing, whatever you want to call it, his little stage setup at home. So we're going to build kind of a modified version of our buffer amplifier up here, and we did a video on this, and we're going to see if we can do one that has some XLR outputs as well, and so that we can actually have a balanced output to go into the mixing console. And when we switch it, it'll switch into a 8 ohm dummy load for the transformer to feed into, because you really can't run this without a load on the output transformer. That wouldn't be good for the tubes. And then we're going to use that signal to drive a buffer amplifier that will drive the output. The reason we're going to do that is we want the actual tone of the output tubes and everything to be part of the sound. So we're going to sample the signal that's going to be placed across that dummy load resistor, and then we're going to convert it into a signal output that's line level that can be driving a mixing board or something like that. So if that sounds interesting, stay tuned for the next part. But for this one, this thing's ready, and it's ready to go back into the unit when he gets the tone generator and everything finished. So in the meantime, I wish you all peace, joy, happiness, and good health in your lives, and we'll be back real soon. Take care. Bye-bye.